Hey everyone, so this video is going to walk you through the activity titled Relatively Speaking. All right, so notice on the first page there's 5 questions, but there's a stop sign before question 5. Okay. So I'm going to have you and your table work on those first 4 questions, and let's say 10 to 12 minutes. Okay, working on that. Remember, before you write anything down, make sure you're discussing with your table. And before you discuss with your table, make sure that somebody's reading the questions out loud for the group. Okay. Now today, the person that's going to read for your group is going to be number 1. All right, so if you're sitting at seat number 1, go ahead and read the intro first, and then start with question number 1. Okay, I'm going to ask the guest teacher to pause the video here, and then in about 10 to 12 minutes, or when all tables are done, you can unpause the video, and we'll debrief those first 4 questions before we tackle the last one. All right, so you've had a chance to work through those first 4 questions. Normally I would have went around and captured some responses, but since I'm not there, I'm gonna have to just make up some student responses. Okay. So question number 1, without doing any measuring, which side of the triangle would you estimate to be the longest? How about the shortest? All right, so hopefully you can kind of tell that this side here is the longest. They're referring to that as side B. Okay, so the longest is side B, and the shortest is probably going to be that side there. So the side that connects point A to B, or we can just call this side C. All right, now I probably should have pointed this out, that they're using capital letters for each of the points, or like the corners of the triangle, but they're using a lowercase letter to represent each side. So side A, side B, the longest, and side C, the shortest. All right, so then that puts side A clearly as the middle side, not the longest or the shortest. Okay. All right, question number 2. Without doing any measuring, which angle in the triangle do you estimate to be the biggest? How about the smallest? All right, so it looks like this angle opens up the most, right? So angle B is the largest, and then both of these look pretty small, but if I had to say, I think C would be the smaller angle of the two. Okay. All right, so the biggest angle is clearly angle B, and the smallest one is going to be angle C. Okay. Now, you might have been wondering, like, oh, is that just coincidence that the longest side was B and the biggest angle was B, and the shortest side was C and the smallest angle was C? Well, in the next question, we're going to really, confirm that observation. All right, so you used rulers and protractors to make some measurements. Here, I'm going to give you the measurements that I got roughly. Okay, so side A was about 5 centimeters long. Okay, now, if you didn't measure in centimeters, maybe you measured in inches. Let me do the quick conversion here. I'm just trying to grab a calculator. There's 2.54 centimeters in every inch, so this would be almost like 2 inches. Let's see. Okay, 5 divided by 2.54. It'd be like, yeah, it'd be about 2 inches approximately. Okay, side B in centimeters was about 7 centimeters. In inches, that would be about 2.75 inches. So like 2 3/4 inches. Okay. Side C in centimeters was about 2.7, and that's a little bit over 1 inch. Yeah, it'd be about 1 inch. All right, so those were the lengths of the sides. Now the angles, and these are just ballpark figures. So angle A was in the neighborhood of 34 degrees, plus or minus a few degrees. Angle B was 128 degrees, more or less. Angle C was about 18 degrees, give or take a couple degrees. Okay, so what's the pattern, right? The biggest angle does correspond to the longest side, and the smallest angle does match up with the shortest side, and the angle in the middle matches up with the side whose length was in the middle. Okay. So in general, we can make the following statement, right? The biggest side happens to be across from the biggest angle. All right, biggest side across from the biggest angle. All right, if we label the image, that'll kind of make it a little bit clearer. Okay, so let's label the sides big, medium, and small. So this was the biggest side, this was the smallest side, and this one was the medium one. And then let's label the angles, right? This was the biggest angle. This one over here was the smallest angle. And then over here was the medium angle. Okay. So the biggest side is across from the biggest angle. The smallest side is across from the smallest angle, and the medium side is across from the medium angle. So pretty cool. Yeah. All right, so now that you know that relationship, big angles across from big side, small angles across from small side, medium angles across from medium side, so use that fact to then explain why each of these 4 triangles are impossible. Okay, give a reason why they cannot exist. Okay. So again, we'll work in groups for about 5 to 10 minutes here. Write down some reasons, and then your guest teacher will unpause the video, and then I'll do a debrief with you. Okay. All right, just remember, before you get started, that student at seat number 1 should read the question, and then everyone should discuss before you write anything down. All right, so we'll go ahead and debrief these last questions in 3, 2, 1. All right, so the first triangle here, notice how 2 sides are the same length, right? So actually, let's call this the biggest side, and I guess these would be tied for the smallest side, right? Small and small. Okay, so if they're tied for the smallest side, then their angles should be tied for the smallest angle, right? Because big sides across from big angle, small sides across from small angle. Okay. However, these angles are completely different. Okay. So I guess that's why we would say it's an impossible triangle, right? You can't have 2 sides of the same length being across from 2 angles that have different lengths, right? They'd have to be the same, right? Or if this angle really is bigger, right, then this side should be slightly bigger, maybe like 5.2 or something like that. All right, in our next triangle, really we're going to use the same argument, right? So notice that we have little markings on these 2 angles, right? That's saying that those 2 angles are congruent, right? They're the same size. Okay. Now this one here is clearly a smaller angle, so these 2 would be tied for the biggest angle. But they'd be tied, right, because they're congruent. And so big angle should be across from big side. Big angle should be across from big side. Oh, wait, they're different? That doesn't make sense, right? If the angles have the same measure, then the sides across from them should be the same too. Okay. So either they're both 9 or they're both 9.5, but they can't can't be different values. Okay. All right. In our next triangle, well, remember, big side should be across from big angle. Okay. This angle right here is 90 degrees, right? And that is going to be the biggest angle in the triangle, right? This angle is clearly less than 90 degrees, right? A square wouldn't fit in that corner, right? That angle is also less than 90 degrees because a square wouldn't fit in there. So we can confirm that 90 is the biggest angle, but if we look across, 8 is not the biggest side, right? The biggest side is down here at 10, okay? So yeah, that's a problem. It doesn't fit our pattern. Okay. All right, our last triangle here, we have 3 measurements for the side, 3 measurements for the angle. We're trying to figure out why this triangle is impossible. All right, now most students are probably going to look at the angles, right, and check to see, do those really add up to 180 degrees? Because, we have a theorem that says that they should. Okay, well, here, let's go ahead and pull up a calculator, and we'll check. Although you probably did this already. Okay, so we want 82.3 plus 57.7 plus 40.1. Okay, and that equals not 180, but 180.1. So small problem there, right? Should be exactly 180. Okay, there's another problem with this triangle, and it has to do with the sides, right? So imagine I had some sticks that were, 5 inches long, 6 inches long, and 13 inches long, right? Let's see if we can even create a triangle out of those. Okay, so here I'll do centimeters here. So 5, 6, and 13. Okay, so let's create a segment that's 13 units long. Okay, all right, so that's 13. Okay, and then let's draw one that's 5 centimeters long. And then we'll draw one that's 6 centimeters long. All right. The problem is that this is not going to close. It's not going to create a closed shape. These two endpoints will never meet, right? No matter how much I try to rotate this side and rotate this side, they're never going to close, okay? So you can't even get a triangle with those 3 lengths. You won't get a closed shape. That's kind of the more glaring problem. Okay. All right. Let's introduce some terms here. Okay. So a triangle that has 2 sides that are the same length. Remember, we call that an isosceles triangle. Okay. And what should also be true is if the sides are the same length, then these angles here should have the same measure. We call these the base angles. Okay. All right, so we'll make a note here in red. Isosceles triangles have base angles that are congruent. Okay. Right. And kind of using the reverse logic, if you have a triangle where the base angles are congruent, then it should be an isosceles triangle. The 2 sides should be the same length. So if base angles are congruent, then the triangle must be isosceles, right? So these should either both be 9 or they should both be 9.5, right? And over here, right, if these are both 5, then the angles should either both be 27 or they should both be 25, right? They can't be different measurements. All right, so on the back side, we'll do a quick summary. So the size of the angles, right, small, medium, big, should match up with the size of the sides. Again, small, medium, and big. So let's see, how could we phrase that? Well, let's just write this. Big angle across from big side, medium angle across from medium side, and small angle across from small side. All right. Probably a picture would have been a much better idea here. Okay. So we're going to go ahead and draw. Small, medium, and large. That's horrible. Let me redo that. Okay. Small, medium, and big. Okay. So small side. Big side, medium side, and then we'll just write S for the small angle, B for the big angle, and M for the medium angle. Okay. All right, so big angle across from big side, medium angle across from medium side, small angle across from small side. Okay. All right, so that's kind of our first, skill learning target. The second one has to do with those isosceles triangles. Okay. So let's kind of create some space over here. Okay. So in an isosceles triangle, the base angles are congruent. Okay. Also, if the base angles are congruent, then the triangle must be isosceles. All right, so I'm going to draw kind of like your traditional isosceles triangle. It's going to kind of have a pyramid shape. Let me try to freehand it. All right, so that's the bottom side, and then that'll be the vertex at the top. We'll have a left and right side that are the same length. Okay. All right, so we're going to go ahead and put the congruent marks on those two sides. Those are the ones that are the same length. And then if we look across here, right, these two angles are the base angles, right, and they should be the same, okay, given that the sides are the same. Okay. All right, so your guest teacher can pause it here, leave the quick notes up on the screen, and then we can work for, let's say, another 10 minutes on the check your understanding questions. Okay. Now, I don't want you to do all four. In fact, why don't we just tackle the first three, and you can skip number 4. I'm not a huge fan of that question there, so just do the first 3 questions. Okay. All right, so pause the video on this screen, and then come back in about 8 to 10 minutes. All right, so you've been working for a little while now, and we're going to go ahead and go over the answers to these 3 check your understanding questions. Okay. Let's begin with number 1. Okay. In the triangle shown, PQ is 5.6, so we're going to go ahead and label that. PR is 6.1, and QR is 5.2. Okay. Without a protractor, put the angles in order from smallest to greatest. All right, now something to be careful here is this triangle is not drawn to scale. It's just kind of a generic triangle that they printed. So don't go off of what you're seeing in the triangle, go off the measurements, okay? So I'm going to label this as the biggest side, and this one is the smallest side, and this one is the medium side. Okay. Now that I know where the big, medium, and small side are, I can just look across for the big, medium, and small angle, right? So the smallest angle is going to be right here, angle P. The medium angle is going to be over here, angle R, and the biggest angle is going to be over there, angle Q. So if I rank them from smallest to largest, the angles that is, right, angle P is the smallest, then angle R is the medium one, and angle Q is the biggest. All right, question number 2. Find the value of x plus y. Now this is a pretty challenging question because, well, first of all, we've got to know something about triangles where all 3 sides are the same length. And then we got to do some algebra. We've got y variables floating around there. We've got x variables floating around there. Okay. So if I asked you, hey, which side is the biggest, you'd probably say none of them, right? They're all the same length. So nothing is the smallest side or the biggest side or the medium side. They're all the same. Okay. So if the sides are all the same, then the angles are not going to be big, small, or medium, but the angles are all going to be the same, right? So, you know, the measure of that angle is going to equal the measure of that angle. That's going to equal the measure of that angle, okay? So remember that for any triangle, the sum is 180. So if I take that and divide by 3, I get 60 degrees. So I can say that's a 60-degree angle. This one is 60 degrees, and that guy over there is 60 degrees too. All right, so that's kind of the first important step. Okay, no algebra needed there, just kind of know some things about geometry. This is what we call an equilateral triangle. All the sides are the same length, and kind of the result of that is, hey, all the angles have the same measure too. Okay. All right, now that we know the angles, the angle measures, right, we can solve for x, right? 5x is going to be the same as 60 degrees. 5x equals 60 degrees. Divide by 5, and you get x equals 12. Okay. We can come over here, and we can see that 4y minus 8, that's the same as 60 degrees. 4y minus 8 equals 60 degrees. Okay, so imagine we add 8 to both sides. So now 4y equals 68, and then imagine dividing both sides by 4, and you're going to end up with y equals 68 divided by 4 is 17. Okay. All right, we can do the same thing with the final angle over here, right? 60 degrees is the same as 3y plus 9. So 3y plus 9 equals 60 degrees. All right, so first step would be subtract 9 from both sides. You get 3y equals 51, and then divide both sides by 3, and you end up with y equals 51 divided by 3 is 17. All right, that shouldn't be a surprise because we already knew the value of y was 17, so it should be 17 no matter which equation we're solving. Right, now all that work, and we still haven't answered the question. The question was, find the value of x plus y. Well, x is 12, y is 17. You add those together, you get 29. Okay. All right, I'm going to be honest with you. I'm not sure how important all that algebra is. What I would take away from question number 2 is that if all the sides are the same, then the result is all the angles will be the same too, right? There is no big, small, or medium here. Everything is the same. All right, our last question wants us to explain why triangle GHK, so that's this triangle here on the left, is isosceles, okay? So isosceles means 2 sides are the same length, okay? Well, dang, that's going to be hard to show if we don't know how long any of the sides are. Okay, but we have some angle measurements, so let's start there and see what we can get from it. Okay. All right, if we focus on this part of the image here, right, I might ask you, what's the angle across from 68, right? And I hope that you would agree with me that it's 68 degrees, right? These are what's called vertical angles, right? They have the same measure. Okay. Now that we know two measures of this triangle, I might ask, what's the missing measure, right? And if you aren't quite sure, I might then ask you, well, what's the magic number for triangles, right? The magic number is that the three angles add up to 180, okay? So for now, let me just call this, let's just call it x, right? So x plus 56 plus 68 adds up to our magic number 180, okay? Let me write that over here. X plus 56 plus 68 equals 180 degrees. Actually, I want to move that down here. No space over there. Let's just do it on the side over here. Okay. All right, over here we're going to combine what we can. So that would be, the 56 and 68. That's 124. So x plus 124 equals 180. And now we need to subtract 124 from both sides. All right, so x is going to end up being equal to 56. Okay. So we go back to our image now, erase the x, go ahead and write in the measurement 56 degrees. Okay. So now something interesting happens, right? When we're looking at the three angles, two of them happen to be exactly the same. Okay. So these are, let's call them the two small angles. This would be the bigger angle over here, right? So big angle is across from big side. Small angle, there's two of them, so we're going to have two small sides. Okay, so these two sides over here are going to be the small sides, and they're going to be tied for being the smallest. They'll be the same length. Okay, all right, and so that's how we show this is isosceles. Right, two of the angles are the same. These are called the base angles, by the way. And if the base angles are the same, then you're going to have two sides that are tied for the same length. Okay. All right, remember, don't worry about question 4. So, there we have it. We finished our lesson. So now what I'm going to have you do is, if you haven't done the Desmos activity, I guess you would do the Desmos activity next. If you already finished the Desmos activity, then you can grab a computer, log into Big Ideas or Canvas even, and then work on one of the two assignments.